Welcome to the AGI seminar. Good afternoon, everyone. My name is Pramod. I will be moderating the seminar today. And today we are delighted to have Dominguez, Alvaro-san, to present his fascinating paper. The paper is titled as Sectoral Productivity Convergence, Input-Output Structure and Network Communities in Japan. This is a fascinating paper, and the paper is co-authored with Felipe Santos Marquez and Carlos Mendez, and we hope to learn a lot from the paper. And those of you who don't know Dominguez-san, like he came to AGI this year, and he is an assistant professor at AGI. So Dominguez-san, we are looking forward to the presentation, and the floor is yours.
Oh, well, thank you very much, Pramod-san. So first of all, let me share the slide. I think it should be fine there. So, okay, well, thank you very much, everyone, for joining today, this afternoon. Today,
could you please wait? So the presentation will be for about 30 to 40 minutes, and then within the presentation you are welcome to ask clarifying questions. Yes, and if you want to have a clarifying question, if you can just write in the chat so that I can ask him. And after the presentation, you are welcome to switch off on your mic. Okay, so Dominguez-san, I'm sorry for disturbing you. And
no problem. Yes. Thank you very much for the introduction. So, well, everyone, thank you very much for joining today for this talk. For today's presentation, I want to talk about a work I've been doing. It's titled Sectoral Productivity Convergence, Input-Output Structure and Network Communities in Japan. It's being co-authored, as it was previously mentioned, by Felipe Santos Marquez from Dresden Technical University and by Carlos Mendez from Nagoya University. So there exists a large literature that studies aggregate productivity differences, both within and across different countries. The thing with this literature is that the aggregate patterns that they study in it may mask or hide different complex structures of the production systems. So in order to overcome this type of limitations, or in order to be able to work in a more disaggregated manner, some ways have been proposed, such as the study of sectoral productivity differences, or also through the input-output structure of the economy. Also, the network structure of the economy can play a role as a middle layer that gives us information or summarizes complex sectoral interactions that can be occurring. Also, it provides us with some explanation for this observed aggregate patterns that might be inside of these structures. Besides the literature at the national and at the regional level, we do find some literature. There's more research that is being done on productivity convergence at the sectoral level. In this literature is actually motivated by the notion that aggregate productivity dynamics can be explained by productivity dynamics at the sector level. So by identifying the convergence or divergence dynamics of certain important or even key sectors of the economy, we can derive, or we can get some policy targets or even some benchmarks of the performance of the economy. So many studies actually evaluate sectoral the productivity dynamics in the sectors, but they do not explicitly treat for this input-output structure. So some ways have been proposed to deal with this. For example, one is to evaluate the input-output structure of the economy, but through so-called network communities. I will explain briefly soon what a network community is, but the basic idea is that it's a subgroup from the whole, right? So if we think of the economy as a network, we can think of a network community as a sub-network. Also, by identifying the most important or central firms across these industries, we can deal with these types of issues. So I've mentioned before a network, but different people might have different understandings or perceptions of what a network is. So throughout this work, at least we define a network as a collection of elements, which we will call nodes or vertices, which are connected through some type of relationship of interest, say links or edges. So if we look at the picture below, we see an example of a network. In it, we see that the black circles are the nodes, which can represent individuals, countries, firms, etc. And they are connected to each other through lines called edges, which can represent, say, friendship, trade, any type of business relationship, etc., that we're interested in analyzing. The interesting thing of this is that this networks with their architectures or their structures actually arise in many or various contexts. For example, in technological and transportation infrastructures, say a subway system or even any transportation system in a country can be an example of a network. Social phenomena such as social networks or even friendship networks, society can be also expressed through a network. Biological systems, the distribution of animals in a certain geographic region can also be explained through this network. So given the fact that many relationships are network, if we can understand this architectures or structures, it can help us in recognizing certain behaviors that we might be of interest to us and their possible outcomes. And also, I mentioned before a network community. So defining what a community usually can be a very abstract exercise, or we can have different definitions, but at least in networks, we will say that a community is a subgroup or subnetwork in which the members or the elements that belong to a given community have a higher probability of being connected to other members of the same community than with those outside of the community. So in a more visual way, which might be easier to understand, in this graph here, we have 3 communities. Each has a different color. So at the top left, we have the white, top right, we have the yellow, the bottom, we have the orange one. So if we check, for example, the white community, we see that each of the nodes inside of it have more connections inside than outside. So it's locally more densely connected than with those members that are outside. The red links are actually the so-called bridges that connect the different communities, and they help to connect them and provide the different types of information that might flow from one community to the other, or goods, or different types of relationships of interest that we might have. So we could even say, for example, the idea is that people tend to gravitate towards those who are more similar to them, or who have similar interests, backgrounds, religion, language. Or in the case of firms, it could be also the case of firms that trade more with each other, or that have certain long-term business partnerships and have incentives to trade more with those that are similar or that have more relationship to their relative business. So what's the importance of finding communities? So by understanding this community structures, we can actually have some interest in insights into why certain nodes are associated with others. Okay, why a given community is composed in a certain through certain industries or certain firms, individuals, or whatever we want to analyze, and not with others. Also, communities usually have different properties than the rest of the whole network. So it can be a daunting task actually to analyze a whole network if it's very large. So by analyzing subgroups of it, we can have a better idea or a more general picture of what's occurring given certain pattern of interest that we want to analyze. And finally, we will say that the membership of these communities actually can give us important information regarding the relative positioning of either nodes or groups. What this means is certain nodes or certain groups of nodes might be more important or influential than others. And by finding where they are located or in which groups they are located, we can also see who they interact with. And in many cases, even the most important or influential nodes are also connected to other nodes that are powerful, influential, or important. Okay. So the aims of this paper are twofold. We can actually reduce it into two main aims. The first one is to study sectoral productivity convergence for the case of Japan, and do so through the input-output structure and through its network representation. We work with 106 production sectors in Japan, and we use both community detection algorithms and some centrality measures to see the relative positioning or importance that certain sectors have in the economy. We then also rely on two definitions that I will soon explain that are stationary communities, and we expand it into a robust community. We then evaluate the evolution of productivity, either if there's convergence or divergence, in each of those communities that we find. In order to do so, we rely on parametric and non-parametric frameworks of convergence of sectoral productivity. The contributions of these papers are, I will spoil a little bit the story, basically is first we study the industrial dynamics in Japan, but through the complementarity of two different methodologies. One being this community detection algorithms from the field of network science, and the other one being through alternative convergence frameworks that are fairly standard in economics. The second contribution would be that we discover certain communities, but that have contrasting convergence divergence patterns. For example, we find that there are strong diverging signs in community 2 that might be responsible for the weak divergence that we find for the overall 116 districts. Okay, so having explained all this theoretical background, we can now move on into the paper in itself. So the first thing we do in this paper is we rely on two different algorithms. The problem of finding or detecting communities in very large networks can be that it's very computationally intensive. So humans cannot do it. There can be so many different combinations. So what we usually do is we rely on algorithms to do this. The two algorithms that we rely on are, the reason why we rely on actually on them is because they're very efficient. They can find communities in a reasonable amount of time. And also because the approximations of communities that they find are fairly accurate. Okay, they don't necessarily will match with the exact community, but the approximations are fairly what would be expected. And once they are used in small, well-known communities, usually they find them very accurate. Okay. The thing with these algorithms, though, is that they work for a single year. That is, if we work with a given network, it will find a community for that network. But since we're working with a series of networks, given the dynamic nature of this network, that is, production from sector to sector might be increasing or decreasing, we might find the case that for a given year, a given node belongs to a community, but in the next year it has shifted to another community. Okay, so there's like an entrance and exit of certain nodes from communities. So in order to fix this, we rely on the notion of the definition of a stationary community. What this means is we run the algorithm for each year, and then we consider that the members that remain in the same community throughout time will belong to the stationary community. That way, even if for a single year a given node is not present, it's excluded from the stationary community so that it's easier to analyze. Then we also rely on another notion, which is the robust community. Because we're using two algorithms and they are approximations to these communities, it might be the case that a given algorithm will find a community with a certain membership, but the other one might have slightly different members. So basically what we do is we consider the robust community to be that in which both algorithms find the same members for the same community. Okay. Basically, it's the intersection between both algorithms for stationary communities, and that will be the robust community. Here we have a very simple way to explain how the algorithms work. We rely on what is a dendrogram. Basically it's a tree. Okay, so the first algorithm, the one that is called the leading eigenvector algorithm, basically what it does is at each step it partitions a given community into two based on a scoring system. Okay, so at each step it will partition it based on that scoring system, and it will continue doing so either until the point in which the scoring system is no longer positive, or until it reaches a point in which it cannot be partitioned anymore. Every node belongs to its own community, to a singleton community, which is at the bottom of this tree that we can see. It's the extreme case. Okay, so usually it will continue up to the point in which the scoring is maximized, and that will be considered the optimal partition. Okay, and that is the community that is considered to be the real community, or the best approximation. The second algorithm, which is the Lovine algorithm, and it's given the name due to the 4 researchers who developed it were from the University of Louvain, actually starts from the reverse point. It starts from the bottom of the tree. It starts from the point in which each node belongs to its own community. It randomly chooses one. It analyzes each of the possible neighbors with whom it's connected, and it tries combining one by one with those possible neighbors. It sees with which it gets the highest score, and that will become the new community. Okay, both are combined, and the same is done for the remaining nodes. Each is combinatorially combined through each of the other neighbors. That's the first step. The second step, it will be that new community that has been formed of 2 nodes will be considered one node only, and once again it will be analyzed with the other connections or neighbors that it has to see with whom it maximizes the score. This process will continue until either the scoring system is no longer positive, or up to the point in which all nodes have joined into one single community. The partition that gets the highest score is the optimal partition. Okay. Okay, so the data that we used for this analysis is we relied on input-output tables from IETI, from the Research Institute of Economy, Trade, and Industry. We relied on the 2015 version of the GIP, the Japanese Industrial Productivity Database. This database goes from 1970 to 2012, but we worked with 10 less years, that is from 2003 to 2012. We also used labor productivity data series for each industry, and we computed them based on the gross real output and the number of workers. We consider 5-year, given that we were working 10-year periods, we consider 5-year averages for both community detections and for the study of convergence patterns, so that each period is equally distributed. Okay, so finally moving on to the results, which can be more interesting. When we run the algorithms, we find 2 communities and from 2 robust communities. So from now on, whenever I refer to a community, I will refer to a robust community. Okay, we find 2 communities, community 1, community 2. And then what we do is we analyze the centrality, that is which nodes or which sectors inside each community are more influential or important. And we get this circular graphs, which are very actually intuitive. The idea is that the more to the center that a given node is, the more central that it is, okay? And what we do is we find the 5 most central sectors for each community, and we color them in blue, okay? The numbers that each node has is based on the code, the numbering code that the GIP has, okay? And we find that for community 1, both the finance, which is the node number 69, and other services and businesses. Here below we have each sector, what they represent through their numbering. Other services and for businesses are the more central ones for this period. Basically, community 1 is mostly service oriented. Okay, the most important nodes are mostly service oriented. For the case of community 2, we find that they're fairly stable, and sector 52 and sector 51, that is semiconductors and electronic parts, are the most central. Community 2 is mostly high-tech oriented, oriented community. The reason why the positioning of nodes is shifting sometimes is due to this dynamic nature of the network. So productivity or production or trade between sectors can be going up and down. So that shifts the relative positioning that the nodes will have slightly sometimes. Okay. We then analyze the trends of both the mean and the median for labor productivity for both communities and also the overall. Okay, we have at the top we have both the mean and the median analysis for the original scale, and at the bottom two panels we have them at the log scale. So it's expected that the data will be slightly compressed. Okay, in panel A, we can see that community 2, which is depicted by the blue line, the productivity, the mean productivity for community 2 has gone up throughout the period under analysis. In the case of community 1, which is the green line, we see that productivity increases from 2003 to 2008, but then it plummets until the end of the period, reaching levels similar to that of the beginning of the period under analysis.
Dominguez,
yes.
Can I ask a clarifying question?
Please.
So first is, for example, let's think that let's create a random number and make enter into the algorithm.
Mm-hmm.
So because you are forcing to make community, there might be some chances that it will definitely, even if they are like random farms or random things, they will definitely form communities. So how do you deal with those kind of like random farms? One, and second is that what do you mean by community 1 and community 2?
Okay, so let me see if I understood your question correctly. You are asking me if randomly they are chosen, right?
Yes.
So they are not randomly chosen. Actually, the algorithm, the scoring system is based on some long theory that we can discuss later if you're interested, but it basically finds them based on similarities or those who are more having more interaction with each other. It's not randomly, right?
What I mean by that, if you just also create random, like 1 to 100 numbers,
yes,
and make a community, it will. There are random chances that it will definitely become a. There are some like not non-zero chances that there will be some kind of.
Yes, there's a non-zero probability that it might happen,
yes.
But the idea is that this can be reproduced and replicated n times, and we will always get the same results. Whereas if you do it randomly, it might not be so the case, right? So when we tried this many times, we always got the same results based on the data that we were working.
Okay, thank you.
I'm sorry, the second.
Sorry, by the way, if we compare the figure A and figure C, it's a little strange. Why?
I will get there. Please, just give me a second. I will explain one by one so that it becomes clearer. Okay.
Okay.
No, it's a good question that you have. Yes. So let me go first. So the mean I explained basically that the overall then basically the productivity is going up. The median, the positioning flips because the case of community 1, there are some high productivity outliers that are actually shifting the production upwards. In the case of community 1 versus community 2 in the mean. In the median, we know that this is more robust, so it does not happen. When we work with the logs, we see that we work actually without the outliers in this case, okay? So basically it's organized the same as in the median, but there's also a structural break here in between 2008 and 2010, which could be due to the fact that it's the time of the international financial crisis. But we do not, in this analysis, we do not perform any econometric. We do not do any econometric analysis to understand the causes behind this. This is left for future research because this is just the first initial analysis by combining these two methodologies actually. Okay. What would you like to know about the bottom two plots?
Yeah, the shape should be different. It's okay, but the relative position for the three curve should be similar. Why? The blue curve in figure A is the lowest end, but in figure C, the blue curve looks to the highest. It's difficult to understand.
What we do is in the case of the mean, there were some outliers, productivity outliers that were pushing the mean upwards. So that's why community 1 was on the top. What we do in the bottom two is we take out the outliers. So in this case, it's not longer anymore the case. Okay, that's what was shifting upwards everything. So when you see the median at the top, it's robust to this outlier. So this positioning is also flipped. So it does not happen anymore.
Okay, go on, please.
Okay? Yes. Okay, so we then start analyzing whether there's convergence or divergence through the parametric analysis, right? We rely on sigma and beta convergence analysis. In plot A to the left, we have the beta convergence analysis through the standard deviation of the log of labor productivity. So what we see here is that basically the plot is showing an increase in the dispersion, implying that there's an increase in that there's a tendency for divergence. But once we perform a formal statistical analysis based on the ratio of the standard deviation of the initial period to the standard deviation of the final period, we find that it's statistically not different than 1. In other words, this means that it's not statistically significant. What we do then is we test for beta convergence, which is shown in plot B, and we see that we have 6 linear fits, each for the 4 consecutive year transition periods. The 3 first ones are upward sloping, implying that there's divergence. The 3 latter ones are downward sloping, implying that there's divergence. But of course, we test for statistical significance, and we find that only the first 2 curves are statistically significant. So for the overall of the 106 industries, we cannot clearly say what is happening. We cannot say if it's converging or diverging. Okay. So what we then do is we analyze, but for each separate community. In the case of the panel A, we analyze and we see that community 1 is the dispersion is increasing for the period that goes from 2003 to 2005, and then the dispersion decreases. For the case of community 2 in panel B, we see that the dispersion increases. The divergence seems to be the norm, basically. But once again, when we perform the statistical analysis, we find that it's not statistically different than 1, the ratio that I mentioned before. So it's not statistically significant. But we think that if we can work with data that extends up to the end of the year 2010s, this might become statistically significant because of one of the reasons could be the structural break that I mentioned before. But we need newer data to work with in order to extend this. So what we do then is we also analyze the beta convergence. In the case of community 1, we see that only the first period has an upward sloping curve, but from then on, all the other 4 transition year periods are downward sloping, and the last 2 periods are statistically significant. We then check through a robustness test by extracting the outliers that I mentioned before, and we actually find that another period is added, and the 3 last periods are statistically significant, implying that we are finding some signs of convergence. In the case of community 2, we see that all the curves are upward sloping, but each period, the slope starts going down. But so if we think that if we extended also the time period, maybe either we would find that we are reaching a steady state or that there are slight convergence. But nevertheless, for this time period, all the slopes are upward sloping. So there's signs of divergence. Okay, but this is with the case of parametric convergence. So we also test for the case of non-parametric analysis, okay, which can give us more information. We first start analyzing the overall of the economy. So we have in panel A, the kernel density, and in panel B, the modal box plot. I think it's easier to explain from the modal box plot in panel B what is happening and then from A. So basically what we have here is we see the relative labor productivity for a given year T with respect to that same labor productivity, but plus 4 years in the y-axis. The boxes that appear in the main diagonal are the modes. And we see that in the lower tail of the distribution from say 0 to 6, the modes are located mostly on the main diagonal, implying that there has been no shift in productivity throughout this period under analysis. But come 6 to around 10, we see that there's an upward shift from some modes that are located in the yellow box, implying that there are signs of divergence clubs or club groups of industries that are diverging. We also see that from around 10 to 15, there's a group or club of industries that are shifting downwards, implying that they are diverging from other industries. Nevertheless, we also see in the upper tail that there's a group of industries whose pattern is not very clear. Some are going up, some are going down. So in the overall, we do find some signs of divergence and convergence, but we cannot rule which is dominating which just from this. And in panel A, we just see basically this, what we saw in panel B, but in the 3D version of the distribution. So what we decide then to do is analyze this behavior, but in each of the subclusters, the clusters or the communities that we found before. So when we analyze for the case of community 1, we see that from the middle of the distribution, it's highly unfairly distributed because there are no industries are concentrated in the middle. But in the lower tail of the distribution, all industries, the modes are concentrated along the main diagonal, implying that there's no shift in productivity. But from around 9 to 13, basically, we see that there's a downward shift from those modes that are in the blue box, implying that there's signs of convergence in this community. And the upper tail, once again, has the same behavior as in the aggregate, which is not very clear. In the case of community 2, once again, we see that in the middle of the distribution, there's no concentration of industries. In the lower tail, has the same behavior. Most are not shifting their productivity throughout this period under analysis. From 6 to 8, also fairly stable, remain in the same main diagonal, but the upper tail has a large increase or jump in productivity upwards, implying that there's a divergence club. The interesting thing is if you check this blue and yellow box with the previous graph, you will see that the relative positioning is the same. So the ones that are in the blue and the ones that are in the yellow are approximately the same ones, and they're located in the same y and x axis. So what this is telling us is that once we disaggregate, we can see more clearly that in community 1, there are signs of convergence along with community 2 having signs of divergence, which are reinforced with the previous findings of the beta convergence, that there were some signs of divergence in community 2 and convergence in community 1. So basically, the central finding that we can say is that we find that some members of community are converging, while some members of community 2 are diverging. this convergence is to a low productivity equilibrium, while the other group, the community 2, might be escaping from a low productivity trap. There's a growing literature that aims to explain this productivity slowdown of Japan after the 1990s. But we, at least in this work, we are not trying to find the causes of this. This is left for future analysis. But nevertheless, these previous findings can help us contextualize and interpret what the results could be. So we think that community 1 could be suffering from insufficient investment in information and communication technologies, as well as in intangible capital. Also, in the case of community 2, some large high-tech manufacturing firms kept improving their productivity, but this technology spillovers didn't come through into community 1 because of different constraints in differences in scale and size. This could be one of the reasons, we think. Of course, I think it's important to discuss some potential limitations that this study has. So this is an initial intention of combining 2 different types of methodologies, right? One is from the community detection field, and the other one from the convergence frameworks in economics. So communities, in order to work in this methodology to work well, we require that communities are sufficiently large enough. They have to have at least 30 members or more, so that especially the non-parametric models can work well. Otherwise, the results that we would get are not very good. So this can be solved, of course, by working with larger input-output data sets. This would allow for not only detection of larger communities, but also even more, a larger number of them, and allow for both an analysis inside of each community and across communities. Also, the selection of undirected and unweighted relations can be a strong assumption that we make. This is just a preliminary approximation to evaluate how these trait links and the formation of these communities may be affecting the convergence of labor and the pattern within these communities that we see. So further research can actually be done using the latest data. Actually, this morning I checked, and I should have updated this, is 2018. It recently has been updated to 2018, the latest data. When we were doing this analysis, it was first not available, then up to the year 2015 became available. But the problem is that this new database has different assumptions, such as how they treat research and development expenditures and capital formation is very different than the data set that we were using. But by using newer data, maybe we can get a better understanding of what is happening in community 2. Also, another problem with the newer data sets is that it has less, the number of industries is smaller than the ones we were working with. We originally worked with 106, but the newer ones has 100 or even less. And we found that 1 or 2 of the most central industries are not present in the newer data sets because they could have been aggregated with another, or simply the name has changed. So, okay, so in conclusion, basically, what we did in this analysis is we rely on two community detection algorithms to partition data of Japan for the case of input-output data. We find some common industries through these algorithms, and we find that they remain in the same community for a stable amount of periods, for a specific amount of time that we are analyzing. Industries that belong to the same community are those that have higher or more frequent trade with each other. And we find that community 1 is mostly service-related industries, whereas community 2 is mostly high-tech manufacturing industries. For the period of 2003 to 2012, we find no patterns of very specific beta or sigma convergence for the overall economy. So once these industries are subdivided into both communities, we find some signs of convergence in one of these communities. And when we consider the 4-year labor productivity transitions, we find that after 2007, the beta coefficients in community 1 are statistically significant. In the case of the non-parametric approach, we find that there's a formation of convergence clefts that differs between the communities and the whole sample. Community 2 clearly shows some signs of diverging patterns, and community 1 has lower productivity growth for most industries, especially in the upper tail of the distribution, which could be suggesting strong patterns of convergence. So, well, thank you very much. And if you have any questions, please let me know.
Thank you very much, Dominguez-san, for interesting research on network and community analysis. So now we will go to the question and answer round. So if you have any question, please turn on your mic and please start. You can free to ask question. Yes, Takagi-sensei.
Obviously, I don't understand the methodology, so I maybe say some wild comments, but I have both comments and questions, or comments / questions. First of all, your motivation to pick Japan, to study Japan, is because of its slow growth in productivity and how to explain it. Is that the motivation?
We started analyzing because
Yeah, okay. Now, if that's the case, why would, grouping sectors into community is the best way to do that, okay? And it's not very convincing. That's the approach one should use. It seemed like you wanted to just use this methodology, and afterthought, you decided to apply this to explain productivity. Now, the second thing is whatever methodology you use, algorithm, whatever you call, you could come up only with 2 communities in all of Japan, right? Why not 10 communities, right? I mean, that's not very clear to me. And then the third comment I have is that, Japan is an open economy. And especially during the past 2 decades, Japan lost like 500 manufacturing jobs, right? Many of which went to Asia. And why is it important to analyze the networking of domestic sectors without really considering its foreign connections? So, I mean, those are sort of just a random thoughts I have. I mean, but by the way, I really like the paper, and I think it's great work that you're doing. It doesn't have to be perfect to be good, right?
No, thank you very much for your comments. I think you're right. I think in many things, this is an initial. We were trying to combine different methods. The basic idea why we started this, actually, which is a good question, is one of my co-authors was working with a different methodology. He works mostly with the convergence frameworks. And he could not explain certain behaviors that were happening in some data that he was working on. So he was trying to partition or work with subgroups or clusters with other methodologies. So I proposed using this methodology that I was familiarized with. And we analyzed this kind of data because we thought it would be a good initial way to try this methodology. And we found some, of course, there are many things we could criticize. I agree a lot of things that you said. I think you're right. But at least as an initial try or initial way of using this methodology, we thought it was interesting, the different results we could find and how the clusters were composed of. Of course, ideally, I think there would be more than 2 communities, of course. Probably there are more than 20. But we do find that those communities, if they're partitioned into such small numbers, given that there are 106 sectors, one of the 2 methods fails, actually. So when we work with this data, it just so happened that it was working well. So that's basically the idea of why we find the 2. The algorithm just happens to find 2. And when we try with both algorithms, both find exactly.
So because you are using, so that your definition of robust communities, that both algorithms come up with the same
or coincide,
right? Yeah.
Otherwise, if it's completely different.
Okay. I see. All right.
Yeah.
But that's something to think about, though. I mean, you have to decide which is better. You cannot just say that, okay, there are two methods, and we are going to select only those communities both of them identify. I mean, what's the logic, right?
There's an economic logic behind each of the algorithms also, right? Both are maximizations, and the one that is divisive is actually, the one that is aggregating is actually trying to maximize finding the communities that maximize their utility to the trade. And the other one that is dividing is actually trying to cut those connections that are actually not maximizing and trying to only focus on those that are maximizing its trade. That's basically the idea, the economic intuition behind those two. And the point in which both algorithms reach a consensus is basically the best partition.
Could I ask
please
a few questions? Yeah, thanks very much. Very interesting presentation. But like Takagi-san, I'm totally amateur in this topics, this methodology. So I don't know if my questions are sensible. But one thing I would be interested, I have about 2 or 3 questions. One is, could you tell us exactly which sectors are in community 1 and which sectors are in community 2? I'd be very interested to know, and that would help us judge if it's a plausible, taxonomy. If they're 2 totally unrelated sectors in one community, then it might, cast some doubt on your methodology.
So let me share the screen here. So what we make focus, can you see the screen, right? What we make focus here on is on the most central ones, right? So the most central ones we find in community 1 are construction, wholesale, finance, rental of office equipment and goods, and other services for businesses. And,
okay.
And
so that's why you said it's largely sort of service related.
Service related, yes. Yeah. Those are the most central ones, right? And in the case of community 2, you will see it's household electric appliances, electronic data processing machines, communication equipment, semiconductor, and electronic parts. So it's mostly high tech or electronic service, electronic companies, right?
So mostly manufacturing.
Manufacturing, right? Yeah.
I see. Oh, okay. Thank you very much. Yeah, that's. I guess you already covered this, but I wasn't paying attention.
It's a lot of information. I can understand.
Yeah. No. Okay, thank you. And my second question is, you find, very divergent trends in the 2 communities. And I was wondering if you had any idea about the reasons why there are such divergent trends in these 2 communities in terms of whether there's convergence or divergence.
Okay. Yes. So that's a good question, actually. The thing is that we don't perform an econometric analysis behind this to find what are the causes of this, of what is happening. Otherwise, the paper would become too long already. So we leave it for future research. But we are working actually on that. We are starting to work on that because we think it's a very interesting venue of research. But for this is just an initial work on seeing if the methodology works and what can we find on it. But
Right.
Yeah, I agree with you.
Okay, good. I'm glad you're going to do it in the future. And my third question is, are there any policy implications? And in particular, I was wondering, do you think convergence is better or divergence is better? Is there some normative spin to this?
So the convergence divergence, which is better, it will depend on from where are you converging to and from where are you diverging from.
Oh, okay.
So the idea is we can say what we find is that the divergence is occurring from a lower productivity trap because those that are diverging are actually diverging from a lower point and are increasing their productivity and they are pulling everything on average up. So that could be a good thing. It's not necessarily a bad thing. And the convergence could be from a high point actually to a midpoint, or it could be from a low point to an even lower point, okay? But in this case, the convergence is actually in the service sector, which actually became very stagnant because, well, the labor market in Japan is very rigid, right? So that could be a reason why there's convergence. Productivity has been going down, whereas the other ones are actually increasing, and those are the driving motors behind the behavior we find. That's what we would think, okay?
I see. So it's convergence is not always good or bad. It depends on the exact situation.
Exactly, right? It depends to where and from where.
Right. Okay, thank you very much. That's my main questions, yeah.
For your questions.
Okay, any other questions? Yes, like if like
Right.
when you are thinking, yes, Hata-sensei.
Okay. This is a follow-up questions to Professor Horioka's question. I think Horioka-san asked, what is the sort of future, the possibility of future sort of examination of policy applications? Granted that this is the initial stage, but what are the possible policy applications
in behind this, right? So that's a good question. I think that so the policy implications that we get with this is that by finding which are the most central sectors, we can try to understand if those sectors are actually lagging behind, or if those are the sectors that are actually becoming more productive. So the government can actually do some strategic investment or promotion of these sectors if they are actually, for example, in the case of divergence, if we find that finance or other of those semiconductors actually are becoming very important, there could be, but of course I cannot say that just from the analysis we did, but there could be some other demand from other countries, or even local demand could be the ones that are pushing this. So there might be some incentives actually to invest more in those kind of sectors due to the increase in productivity that we find. Also, in the case of the lower productivity ones, by finding which are the most central ones, we can see also if we could try to find some causes of why they are actually lagging behind, and whether they are actually, as a part of the economy, are they sufficiently strong enough or not to actually do something about it. If they're just because of changes in technology, or because they are becoming obsolete, maybe it's just a market trend or something that is happening. But we cannot say just from the analysis that we did what exactly could be happening, but we can have an idea exactly which sectors and the relative positioning in this economy are having, and we can get some ideas of why they are actually lagging behind.
Well, if one sector is growing, it's not enough reason for the government to promote that. I think the private sectors may, be able to do well to finance it, and to justify the government intervention, you may need some sort of networking and so forth, sort of external effects. But the kind of pinning down what are the externalities in that particular industries that cannot be promoted by the private sector seems to be the key, and whether and to find that out, whether that industry is growing or declining in terms of productivity, it seems to be irrelevant. It's just the existence of externality itself is more important, isn't it? Proving that seems to be a and I sort of wonder, sort of how this very, sort of systematic study of convergence and this divergence can help identify the cause of these externalities.
So, for example, in my understanding of the externalities, in this case, the network plays a very important role.
That's right.
So seeing which of those very highly productive industries are connected to which ones, we can actually see how they are actually affecting, and also with how those second industries are connected to others, we can also see how the chain moves on, right? So in that sense, if we find the highly productive ones, we can see how there's like kind of like a, I don't know, how do we say, like an effect, like a diffusion effect, or how that externality throughout the network.
Yeah.
Way to analyze it.
Yeah, but just because Google and Meta provide the social infrastructure for the networking doesn't imply that the government should subsidize them. And so, what is the sort of room for government policy intervention? And that question is not directly related to whether the networking industry is growing or not.
Yeah, I agree with you. Yeah.
So if your final objective, at least part of your objective, is to identify the government, sort of room for government policy to promote particular industries, I think there's something else to study, I think.
Yes. I haven't worked yet on the policy implications, to be honest with you, but I think that's also an important part to work on. And as you mentioned, just because the one industry is being more productive doesn't mean that the government has to.
Right.
I agree with you. Yes. Yeah.
Okay, thank you.
Very much. Good thing to keep in mind.
Any other questions?
Oh, could I just ask one short question?
Of course.
In terms of the algorithm that you use to identify community 1 and community 2, you relied only on the information from input-output tables, as I understand. So you looked at the extent to which these sectors buy and sell products and services to each other. But isn't it possible that networks are, created through other means? For example, whether managers of two companies go drinking together, or whether they have a common technology. So aren't there other sort of criteria that you could use to identify networks or to identify communities?
You are absolutely right. That's a good question. There are many ways actually to analyze. We are not dealing with what is called network formation in this case. We assume that the networks are already formed. We do not find the cause. So these networks are exogenously given. What you're asking is, in the case of, would be an endogenous network. In the case of, there's a model that is explaining why this network formation happened. I am not working with that, but there's some that could be done for that. You've given me a good idea for future research. But as I mentioned before, we work basically with undirected networks, and so there's we do not account for asymmetry even in this case. We're just seeing for if there's a relation or not if, why that relation exists, how it created, or anything else. That's due to a limitation of power that we have in the computers. But there are some people working on newer algorithms, so maybe we could try in the future. Yeah.
Okay, thank you. Yeah.
Thank you very much.
Any other questions?
If there's still time, I want to
Please.
give 2 comments. The first one is that to some extent, the trend of sector productivity convergence it depend on the number of sector. So we know in Japan there are several level of sector classification. Bigger level, diagonally, bigger level, middle level, and shogunry. I don't know how to translate shogunry in a small level classification. So which level classification of sector is suitable for your analysis? This is the first question or comment. Second one is that compared to the sector productivity convergence, there are more studies on the regional productive convergence. The reason is clear because the regional productive convergence is directly related to the regional disparity or regional income equality, which will cause the bigger problem, particularly in larger countries such as China or the United States. The regional income equality will cause many political or social problems. So, but in case of sector productivity convergence, maybe other professor have pointed out this. What's your research in motivation? If you say convergence sometimes it's good, sometimes is bad. So there are no very urgent need to research this issue. This is just my some feeling. Okay, this is my 2 comments.
So yeah, of course, I had the same question as you at first when I thought about it. So if convergence or divergence, depending on which one we're analyzing is good or bad, what's the meaning of analyzing this? But by understanding what's happening, actually, we can see what are the trends of the economy also, right? We can see if some sectors are doing better than others, and we can try to find the reasons behind this and actually do something about it. Otherwise, we could also say the same, if like growing is good for people because the GDP increases, but it's bad for the environment. So what's the good thing? We have to create policies based on that, and the idea is to improve the quality of life. So I think by understanding if it's converging to a lower point or to a high point, and if it's diverging from a high point or a low point, also is very relative and very important to understand, to see the trends of the economy, basically. And the first question, I'm sorry, I'm not sure I understood your first question. Could you repeat it, please, one more time?
First question, I say the trend of sector productivity convergence depend on the number of sectors.
Number of sectors, okay.
Yeah. So, for example, in Japan, there are diabunry, chubunry, shobunry.
Yes.
So there are many kinds of classification. So, in your analysis, which kind of sector classification is suitable for you, for your analysis?
Well, I honestly have not heard of that classification, but I can ask my co-author, who's the one who did this analysis, and ask him if he classified it in a certain way. And if you are interested, I can get back to you and let you know what he said. I honestly don't know the answer for.
Or maybe I should change the question. In your study, how many sectors are classified?
So we work with 106 sectors.
106.
Yes. It's sufficiently, the input output is sufficiently big enough for that limitation that we were having, that it has to be more than 30, right? So the observations were sufficiently big enough, but we would like to work with newer data sets that have more sectors, of course.
Dai-san, would that be medium classification, like 106 or?
But maybe in Japan, it's regarded as chubunri.
Chubunri, yeah.
Chubunriだと思う。
Okay.
And one of things I found a little bit although I don't understand anything about network analysis, one of the things like if you think about Japanese industries or something, you'll find that everyone talks about the automobile industries and banking industry, which are very, very important for network, or like they are the center, and then others are kind of the periphery. So in your analysis, like I don't know, especially like banking, automobile, and especially robotics of manufacturing equipment. So I don't know whether those industries are like, although I don't know, but in your analysis, they do seems to be important, right?
Well, first of all, robotics and a lot of banking appears, but robotics, I think, is sometimes aggregated because of how it's classified in the input-output table. It doesn't necessarily appear like that. I would tend to think also, yeah, maybe robotics is very important or not, but at least with the methodology that we employ, it does not appear as the most. It does not mean it's not important. It's just not one of the top 5, right, that we were finding for the period under analysis. So it could be that it's for another period, or it could be that once we have a bigger input-output table in which even more industries are disaggregated, we can actually find it more clearly, right? But otherwise, no, it did not appear like that.
How about automobile industries? There is no, because automobile plays a very important role since a long time ago, right?
Yes, yes, yes.
Yes, but I don't know.
When we worked with previous years, we found that automobiles was higher, but at least for that, say 1980s especially, we found that it was one of the most central industries. But since we're working with a latter period, it does not appear like that.
And another thing, I don't know, how do you do the algorithm? So generally, like if my understanding is okay, you test your algorithm using the test data, and then you apply to some, for example, like you make half of the data as test data, and you make your, for example, R square stronger or something, predict the algorithm, and then you use it for the final data. So it seems your analysis is kind of a little bit different, right?
It's different. Yes.
Yes.
Yeah, we do not test for R square. So you have a given network.
Yes.
And then what it does, the algorithm is it will generate it will create randomly another network with similar characteristics, but every node will have the same number of connections, but it will be randomly assigned. And then you will test which one coincides and which one it doesn't. The ones that coincide are not considered to be part of the community because you don't generate randomly a connection with someone. You generate it because you have a reason behind it. So those that don't actually coincide are considered part of the real community. But we do not test for R square. We do not do those kind of things in the algorithm. It's just finding the structures that we find and that the algorithm gets, right?
Yes. And another thing is that, like, if you just see the, although I don't have the table and everything, like if you see the table,
We share
figure in 11,
okay.
slide 11, it's kind of like you are analyzing the 2003 data and 2011 data also. There is no change in the in the sector. Even the 10 years have passed, the same sectors are present, are in the top 5.
Yes.
You would expect, for example, like in 2003, this might be important sector, and in 2012, you find like different sectors. But even if there is no change in community 1 and community 2 at all, what might be the trend?
I think that is due to how we perform the robust community. So that if there had been more movement, it might have been excluded from this analysis. So it's very controlled actually when we get these robust communities. So there are always the same sectors. That the relative positioning basically remains similar. You see that they only slightly move, but not so much. So that's something that we can look into for future papers. Actually, that's a good comment, I think. Yeah.
Okay. Any other comments? If there is no other comments or suggestion, I would like to end here, and thank you very much for attending the seminar and listening to Alvaro. And thank you very much, Alvaro. It was very, very interesting. And although we don't have any knowledge, but we learned a lot, and it was very nice. Thank you very much.
Thank you. Thank you so much.
Thank you.
Much.
So see you next month. Yes. So
Yeah, the network analysis approach is very interesting and unique. At least in AGI, you are the most
I'm still learning, so I think a lot of the things
important expert in this field. You should keep your.
I will. I have to learn a lot still. So thank you very much.
yes. Actually, I was personally talking to Alvaro-san. It seems one of the co-author is a mathematician.
Not this paper, a different paper I'm working on.
Okay, sorry.
Is a mathematician, but that one is a theoretical paper, no data.
Okay, not data set. Okay.
Yeah. But no, this one, no. We're all empiricists, so no.
じゃあ、お疲れ様でした。
ございました。
堀先生、コメントありがとうございます。
ありがとうございます。
はい。